Welcome back to our class. Today we're going to be discussing the memo of paper 2. We're going to be discussing about this paper and then we see where we went wrong. And then those highlights where some students were challenged. Yes. All right. Not going to go through the instructions. Let's go straight to the first question. They're saying that consider the following diagram. So here you have the diagram, and then here you have propane. And then propane, what do you form? You form compound X. The moment you add the PT, it can be PT, it can be nickel, it can be palladium. Yes, once you see those catalysts in presence of a hydrogen, and then here you had a double bond, it means that you're changing this compound to be a saturated compound. So it means that this must be a saturated compound. It must be an alkane. It must end with that. All right. So the answer becomes C. So C becomes the most correct answer in that regard. So we talked about this during our prediction and discussion revision before you wrote this paper. They're saying that which one of the following compound has the highest vapor pressure. When you talk about the highest vapor pressure, then it means that it must have the low boiling point. So it must have the lowest boiling point. It must have, then automatically it will have the highest vapor pressure. So if you look at this, this is 2, this is 3, this is 4, and this is 5 carbons. So automatically the one which has lower number of carbons has the lowest boiling point and has the highest vapor pressure. So the answer becomes A. So A becomes the most correct answer. During dehydration, butane 2-ol is represented below. So if you look at that, we're seeing that the major product here, they're talking about the major product. Remember, you can have the major product and you can have the minor product. But if you look at this, it is here because of the, here you have fewer number of hydrogen, and then once dehydration occurs, then it means that since you have 1, 2, 3, 4, and this one is here, then automatically it must be symmetrical. So the compound must have 1, 2, double bond, 3, 4. So you put the hydrogens, 4 bonds on each carbon. So basically the compound must be like that. So when you come here, you find out that it is yeah, you see here 1 carbon, 1 hydrogen, meaning the double bond is there. So B becomes the most correct answer. Then we go to the next question. The next question, they're saying that the complete combustion of 1 mole of butane needs at least. Now this statement makes the everything to be, yeah. So if you do the butane, you'll find out that butane is like that, plus 0.2, giving you carbon dioxide plus H2O. So when you balance it, you'll find out that you need more than 5 moles of oxygen, 5 moles of oxygen here. So at least, so when you say at least, it means that anything which is above 5 is correct. So this makes it to be a vague answer. So meaning that this one is at least, yes. This one is at least, and then this one is also at least because it's above those 5 moles. So it means that I will say that maybe A, B, no, not B, C, and D. Whoever wrote that, you could get. So it means that the question was supposed to be modified so that it is specific to one objective. So I will say that if you got that, they will give you 2 marks, they'll give you 2 marks, they'll give you 2 marks. So it will depend on what they have discussed about. But all of them, they are correct. So it's only this one which is wrong. Then the next question is 1.5, and then they are saying that Maxwell distribution curve of energy, yes, shows the particles, number of particles as functional of function of their kinetic energy, and for the reaction at 4 different temperatures. So the minimum kinetic energy needed for the effective collision, remember we call it the activation energy, yes, to occur is represented, which is here. So now they're saying which of these curves represent the reaction with the highest rate. When you look at the highest rate is the one which is far to that point. So if you look at that, you'll find out that it is D, which takes more particles, which takes more particles, they have more kinetic energy. Therefore, they can react at a faster rate. Therefore, D becomes the most, the graph is D and then the answer is D. So it becomes the most correct answer. 1.6, the graph below, shows the changes in X, Y, and Z. So over time. So now they're saying that which one of the following balanced equation is correct for this reaction? Following balanced equation is correct for this reaction. If you look at it, you find out that balanced equation for this reaction, how many? Okay, if I have one to produce this, because this is a product and these are reactants. So they started from here, and then so if it started from there, how many moles moles were used, and then how many here? So if this is X, so it's 2, which is 1. Basically, is it 1? Yes, it's 1. Therefore, X is supposed to be 1. Yes. Then the Y, each 2. Each 2, ne? Each 2 is 1. So that is 1, that's 1. Because now Y started also from here, so it's going to be 1 mole, 2 moles, 3 moles. You see? Yes. So meaning that each 2 represents 1. So Y is supposed to be 3. Supposed to be 3. Supposed to be 3. So when you look at that, so I will basically need 3 moles of Y. So Y, I will need 3 moles of Y, 3 moles of Y, 1 mole of X, and then this, because there are also 2, it will be 1 mole of Z. So I will look for what is there. 3 moles of Y, 3 moles of Y, 3 moles of Y. Cool. Then 1 mole of X, I have 1 mole of X. This is, all of them are wrong. See, so the alternative are then 1 mole of Z. So A becomes the most correct answer. Then we go to the next question. They're saying that this radical is we call it an ampholyte. It is an ampholyte, means that if it is ampholyte, it means that it's a liquid or is a conductor which can act as a base and an acid. So when you look at this, so this, it comes B. Where's B? B is regarded as, so if it is a conjugate acid base, so when it is an acid, so it will donate this, and once it donates, then automatically it's going to become HPO4, because it has donated this, then -1. So I have to look for that, where it is. Yes. So if it donates, yes, and then if it accepts, if it donates, it's automatically this one. Let me check here. There's something I need to check. Oh, Yeah, so this is just 1. So automatically when it gives out, when it gives out, this is going to be 4. Okay, this is going to be 2. But it's supposed to be conjugate base pair. So if it is an acid, it will donate. It will donate. So if it donates, then this is a conjugate base. It will accept what? So it becomes a conjugate. So this one becomes the unacid. It's a conjugate acid. Yes, because it is able to donate. And then this is a conjugate base of that. Why am I saying that? That this one is able to receive the electron, and then once it receives electrons, it will go back to it. When it receives that hydrogen, the electron, it will go back to that state. And then this, if it loses it, then it will still go back to that state. So B becomes the most correct answer. I explained a number of that in our videos. If you need more clarity, then we can do or discuss about it in other videos. 1.8, the if the concentration of sulfuric acid is 1 to the exponent of -3, yes, moles per decimeter cubed, what will be the pH and pOH of the solution respectively? So if you look at this, you'll find out that when you do calculation, you put it in the calculator, the pH. Remember, the pH is negative log of that hydrogen concentration. So to find out that the pH is this, so wherever you put, you'll find out 2.7. So it is 2.7. 3 is out. So wherever it is 3, it becomes wrong. But now this and this are the same. So because of the pH being 3, so it makes it to be out. So now what is the answer here? What is the answer here? The correct answer is this. But now there is something which you need to look at. If I round off, because this is 0.0000000005, so it's a -11. If I round off to the nearest 10th, so it's gonna be 0.00000001. Because it was 0, so it means that the exponent will change from -12 to -11. You understand? So it means that also this one is correct. However much this is the most correct, but also this one is also correct. So maybe they will give both of them. So the person who wrote this and the person who wrote that, therefore they are supposed to get those 2 marks. Unless the question was saying that which one is the following is the most correct answer. Which one of the following container can be used to store iron sulfate and to sulfate solution? So when it comes to this, you have to look at which one is more reactive, which one is this reducing agent, which one is the oxidizing agent. So if you look at anything which is, when you say iron, yes, it must be something below the iron. You understand? So this one, aluminum is too reactive. It's this one. These ones are too reactive. Ne? Remember, nickel is the one which is a little bit lower than iron in the what? Iron 2. Yes. So nickel, you'll find it's lower in the reactivity series. So anything which can store iron must be lower than, meaning that it cannot displace iron in the reaction. So when you go to the reactivity series, yes, you'll find out that iron is a little bit higher compared to nickel. So nickel is able to store this. So C becomes the most correct answer. So you go to the iron 2. Let me check. Not this one. Where's this one? Where's supposed to be? Okay, let me use this one. This is iron 2, because they said iron 2. What about nickel? You see, nickel is at a lower, meaning that nickel cannot displace what is on top, you understand? So it can only displace what is down. So if you look at aluminium, you'll find out it is up. If you look at zinc, you'll find out it is up. You see aluminium is up above iron, so it can displace iron. You see aluminium, magnesium. So you see zinc, all of them are above. So it's only nickel which is below. So the one which is less reactive will be able to store it perfectly. That's why I say that nickel is the most correct answer. Then they are saying that consider the following reaction. Okay, you have this. And then you are saying that chromium 2, then you have tin 4, then you have chromium 3, tin 2, whatever. The net cell potential in, yes, when this cell reaches equilibrium. Net cell potential automatically is supposed to be 0 if the substance is at equilibrium. That's why your batteries cannot. Yes, all right. So B becomes the most correct answer. So who got 20 out of 20? I hope, guys, you got 20 out of 20. And those who got 20 out of 20, thank you so much. Yes, so let's focus for the next exam. All right, they're saying that question 2. Let's go to question 2. Question 2, they're saying that compound A is saturated compound. Saturated compound or unsaturated compound. Compound A, if you come here, you find out that is 2, 3, 3. So it's a saturated compound. So the answer becomes it's a saturated compound. Give a reason for your answer. Give a reason for answer. It has only single bond between carbon atoms. When you don't say that it has single bond, no, you have to say it has single bonds between carbon atoms. So that between is supposed to be there. Yes, so that you're able to get the mark for the reasoning. Then they're saying that write down the letter or present each of the following. Right. A keton, if you look at a keton is obviously this, it is shown there. So E here, you're gonna get the E. And then they're saying the alkane, you are supposed to look at compound which has a group 7 element. Group 7 element, it has the bromine. Bromides are group 7 elements. So the answer is D. So in this case, the answer is D. 2 functional isomers. It means that it is either alkyl, I told you, is either alkyl, or it is not alkyl. It is either ketone and the aldehydes or carboxylic acid and the esters. So in this case, we will find out that 2 functional isomers, if you look at this is an aldehyde, so I have to look for. So the answer is B and E. So here it comes and then you say E and B, whatever, or B and E. It's the same thing. Consider compound C. So what is about compound C? All right, compound C is an alcohol. They are saying that right. They're saying right is all right. Saying that is compound C secondary tertiary alcohol. Give a reason for your answer. So in this case, compound C. They're saying is it primary? So now, however much it has a branch, but let's go to the carbon atom with the functional group, because this is the carbon atom with the functional group. If you look at it, yes, the carbon atom with the functional group, you'll find out that this one, the functional group, the carbon atom with the functional group has no side group. So it makes it to be, what? It makes it to be nothing. Yeah, it is a primary alcohol. The carbon atom with the functional group has one alkyl group. You see, carbon atom with the functional group has what? One alkyl group. Yes, meaning that the carbon atom that is bonded to the hydroxyl group, that is OH, is bonded to one carbon atom is bonded to one carbon atom. Yes. Then we go to the next question. Write down the structure formula and IUPAC name of the chain isomer. Where's chain isomer? Chain isomer. Chain isomer of C. Now, this one is an isomer. When you say chain isomer, what you need to do is bring this, put it here. Done. Yes, that is it. And then you bring this hydrogen, you put it here. So it means that is going to be, how many carbons are there? I say that it's 1, 2, 3, 4. 1, 2, 3, 4. Yes, saying that 1, 2, 3, 4, 1, 2, 3, 4. So it's going to be 1, 2, 3, 4, and then OH there, and then I put the hydrogens. The hydrogens are supposed to be there with the bonds. Guys, don't forget that these ones, you put them as hydrogen. Don't just leave them as this. We'll cross them. Ne? Yes, you put them as hydrogen. So this is the chain isomer of this. 1, 2, 3, 4. Yes. And then when you come here, it is 1, 2, 3, 4. So basically that is, then you get the answer. Maybe they will give you try them here, and then they will give you, oh, did they say write down the structure and IUPAC name? So it's the say IUPAC name is butane 1 or butane 1 or. So that is it, guys. Then we go to the next question. IUPAC name of D. If you go to compound D. So what we need to do, look for the longest chain. In this case, you'll find out that the longest chain is 1, 2, 3, 4, 5, 6, 7. So it is heptane, because then now if I have, so it means that this is the side group, and then also those ones. So it means that I count 1, 2, 3. So it's on carbon atom number 3. Then all this one is 1, 2. And then it means that definitely this one is going to be the shortest. So I'll say 2, 3 dash dibromo, because there are 2 bromos. The first one on carbon atom number 2, the second on carbon atom number 3, you see. Then di, because there are 2 bromo, which goes the bromide. Then now I put dibromia. Then now I have to bring in this methyl group. 1, 2, 3, 4, 5. Dibroma, dash 5, yes, dash methyl, yes, heptane. That's it. 2, 3 dibromal, 5 methyl heptane. That's it. How do we mark? Obviously, we'll mark this, and then we also mark the side group or the functional, the branches. So that is it. I hope you got it right, guys. The functional isomer of B. The functional isomer of B. Name the functional group of B. Where is B? B is an aldehyde. Yes, B is an aldehyde. So the aldehyde is the homologous series. So the functional group of aldehydes are called formyls. So B is basically a formyl. Yes, it's a formyl group. Then we go to the next question. So the answer there becomes formyl. So you have to write the word formyl there. And then now we go to the next question. They're saying that, yeah, I discussed this before even we went. I said that please make sure that you know how to calculate these things. Some of them a lot of them I discussed about them in our previous, or what you call the last minute discussion a day before, but I hope you guys, you got it right and you managed to score high. All right, they're saying that in the molecular mass, 60 grams, saying the sample of F, okay, contain 40, 30, and then X is hydrogen. So automatically we will subtract. And then if the molar mass, so we'll use it after we have formed the empirical formula. All right, so how do we calculate the empirical formula? You find out the empirical formula by writing here. So it means that you have carbon, hydrogen, and carbon, oxygen, and hydrogen. So in most cases, we arrange them in, we have carbon, hydrogen, and oxygen. So of which carbon, we have seen that it is 40, yes. And then hydrogen is 6,7, and then oxygen is 53,3. Where do I get those numbers? I get those numbers here, the percentages, yes. You see the percentages. How did I get the percentage of hydrogen? Yes, how did I get the percentage of hydrogen? Because it is percentage, so what I did, I said 40 plus 53,3. Then I added, then said, yes, plus. Okay, the hydrogen gives me 100, and then the hydrogen is equal to 7. Yes, when you add and then you subtract it from here, you get 7. So that's why I put it there. So you identifying, because it was not given in the paper or in the, yes, in the paper, therefore automatically you identifying it, they will give you a mark for that. Then they are saying that, yes, so number 2 is we have to divide. So we shall say that divide by the, because this is mass, then you have need molar mass. Yes, a molar mass, which is for carbon, it's 12. So I divide by 12. For hydrogen is 1, and then for oxygen is 16. So that once I mass over molar mass, it gives me the number of moles. So this one is going to be 3.33. It's a recurring thing. And then this one's going to be 6.6. Yes. 6.67 or 6.7. It's the same thing. Yeah, same. And then here is going to be 5.553 divided by this, you get also 3.33. It's a recurring thing. So now after that, I divide by the smallest, divide by the smallest, divide by the smallest. So now after that, you get, this one is going to be 1, this is going to be 2, this one is going to be 1. So now it means that carbon is 1, hydrogen is 2, carbon is 1, yes, hydrogen is 2, and then oxygen is 1. So that is it. But the question is saying that, the second question is saying, so this one you get the marks. Yes. So it must be correct division and stuff. All right. Write down the IUPAC name of the organic compound that will have the molecular formula. Okay, now I don't know it, so I have to find it out. So if I have to find it out, so I have to say that this is equal to 60. So it means that hydrogen, this one is this one is 12 plus, this one is 1 times 2 plus 16. Yes. So that when I add, I get 30. So these ones, I don't know how many. So I put that n there. I put the n there. Is equal to 60. So 30n is equal to 60. So divide by 30, divide by 30. So n is equal to 2. So automatically it means that the carbon is going to be 2. Carbon is going to be 2. Hydrogen is going to be 2 times 2, which is 4. And then oxygen is going to be 2. So that is the molecular formula for that. Yes, so they're saying that write down the IUPAC name of the 2 organic compounds that will have the same molecular. Yes. So since I've got the molecular formula, then automatically, if you look at it, yes, if you look at this, this is a carboxylic acid. It is a carboxylic acid and an ester. But in this case, what are they looking at? They are saying that IUPAC name. So automatically it's gonna be, since the carboxylic acid is gonna be, because it has 2 carbon atoms. If you look at it here, it has 2 carbon atoms, so it means that it's gonna be ethanoic acid. You see? And then the other side, it means that if you split it, the other carbon is going to go there. So it's going to be methyl, methanoate. So basically, this is what I'm saying. It's gonna be CH3, CHOO. Yeah, that is ethanoic acid, and then methyl. It's gonna be CH2. Ne? CH, is this CH2, CH3? Okay, let me write it here and then I see. So it's gonna be, because this one is gonna come here. So it's gonna be CH3. Yes. Yeah, it's gonna be like this, which is methanoate, which is like this. This is 1, 2, 3. Yeah. So basically it's gonna be like that and like this. So the answer becomes ethanoic acid, which is this, ethanoic acid, which is that, and then methanoate, which is that. So yeah, that is how you're supposed to answer that. Question 3, when we go to question 3, they are saying that the compound, okay, the IUPAC name still is organic compounds. We discussed about this. Define the term saturated isomers. Saturated isomers, these are organic molecules which have the same molecular structure isomers, same molecular formula, but different structural formulae. Yes. So that one, you can't go to the paper without knowing the definition. And this is all or nothing. You get it right, or if you don't, if you lose any key point there, you get it wrong. So there is no discussion about that. So 2.3, define the term vapor pressure. Vapor pressure is the pressure exerted by the vapor. The word at equilibrium, pressure exerted by the vapor, that's a key point. At equilibrium, the word equilibrium with its liquid, it's a marking point. If you don't have it, you get 0. Yeah, a pressure exerted by the vapor at equilibrium in a closed system, because the system must be closed. So in a closed system. Which one of the compound B or C will have a higher vapor pressure? Will have a higher vapor pressure, and give a reason for your answer. Give a reason for your answer. So the higher vapor pressure will be, look at it, B or C. B or C. So if you look at the boiling point, the boiling point is this. The boiling, automatically the one which has the lower boiling point will have a higher vapor pressure. So the answer is B. Answer is B. Sorry, the answer is B. And then they are saying that give a reason for your answer. So the answer, you say that, you can say that maybe B has the weaker London force. You understand? You understand? Than C. You understand? Than C. So basically, if you look at C, it only has London forces, this one. While C, it has the dipole forces. You see, it has dipole forces, so it has a higher boiling point. Yes. So you have to explain, showing us what does B has and what does C have, and what makes them to have a higher boiling point. Yes. So what is so if you look at so this one has London forces only, while this one has London forces and the dipole forces. So automatically, the one which has dipole forces will have a higher boiling point compared to the one without dipole forces. So basically, B, which is extended, has a large surface area. Did I skip you? Oh, I skipped a question here, ne? Yes. I skipped a question here. Boiling point B and A. The boiling point is higher. Explain difference in the boiling point. Okay. Yes. The boiling point, sorry guys. The boiling point of, someone is saying that I skipped a question. The boiling point of B and A. This one is 57, this one. Why this one is 57? Because it is branched, while this one is straight. Automatically, if it's branched, meaning that it's more spherical. So if it's more spherical, meaning that it has a smaller surface area. Therefore, it has weak forces of attraction. While B is a straight chain, it means that it has a large surface area, therefore it has strong or has large, stronger intermolecular force of attraction, hence its boiling point is going to be higher. So that's how you're supposed to explain. So define the vapor pressure, I defined it, and then they're saying that compound B and C, we have seen that B is Xn, and then C, it has dipole forces. Automatically, if it has dipole forces, then automatically it means that it will have a higher boiling point. This is boiling point, and then automatically the vapor pressure is gonna be low. So B will have a higher vapor pressure than C. Why? Because C has a higher boiling point. Yes. Then we go to the next question, which is 3 point. Consider C and D. Right, will boiling point of D be X, okay, C, Y, or right? Right only. Will the boiling point of compound be D? Okay, it will be what? Compound D. Consider compound C and D. Okay, compound C and D. So if you look at compound D, this one has dipole forces, while this one has hydrogen bonds. So if it has hydrogen bonds, then automatically it is going to have a higher boiling point. So we have to look for something which has more than 79.8, 79.8, 79.8. This is wrong, and then this is higher. So automatically it means that the answer is Y. So give a reason for your answer. If you look at C, here, yes, C has dipole force, while D has hydrogen bonds between the molecules. Therefore, D has stronger intermolecular forces of attraction. It will require more energy to overcome this, and then to overcome the forces in. It will require D has strong intermolecular forces. You understand? So more energy is required to overcome these forces. Hence, its boiling point is gonna be a little bit higher. Yes. You think clear there? So question number 4 is about the synthesis. They're saying that if you look at this, you see that this is a double bond, has a double bond, is an alkene, and then forms compound, yes, and then from its alkyl, meaning that here you hydrated it. This is hydration because, and then this one, is it hydration? Oh, I added this. If I added this, so if I change this to an alkyl, so it means that it's gonna be the hydrolysis using the base. Okay, we shall see that. You have to know those things in the head. You understand before you start writing about this. So let's start, and then so the first question is saying that write down the IUPAC name That time the type of reaction that occurs at A. So if you look at A, is this one we are adding hydrogen and bromide, therefore it's gonna be hydrobromination, meaning that what is happening here, we're adding hydrogen, so it is an additional reaction. So you have addition reaction. So, since the question is just general, even if you say hydrobromination, bromine is bromination, if it is chlorine is chlorination, chlorination, like that. So even if you say like halogenation, because this is a halogen, all those are correct answers. Hydrobromination, now you are specific to which halogen have you added. Hydrohalogenation or addition reaction, because the question is just open. Then C, when you say C, the one which goes back. So since we are removing this and we are going back to the double bond here, we're removing a hydrogen and a bromide. Therefore, we shall say that that question is elimination or dehydrohalogenation or dehydrobromination. So you are removing the bromine, and so it's just a negative reaction of this. Yeah. So elimination, dehydrohalogenation, or dehydrobromination, all those are correct answers. Then I say another one, write down the name and the formula. Name or formula of a catalyst for D. If you go back to D, which reaction is happening on D? You're from a double bond. So what is happening here? You're from a double bond to a saturated compound, from unsaturated to a saturated compound. So here we expect you to write about platinum. Also palladium and nickel are also used, but we mostly commonly use platinum. So those answers should be marked correct. Then you're saying that reaction B is a substitutional reaction that takes place in presence of water. So if you come back and then you look for reaction B, where is reaction B? This is a reaction B. So it takes place in presence of water. It means that since you are removing a hydrogen and bromide and then you're adding there H2O, basically you're removing this, you're adding that. Therefore, since it involves water there, so it is hydrolysis. Therefore, this to happen, you need what you call a strong base, a strong base, like group 1 bases. So sodium hydroxide dilute, strong base can be like sodium hydroxide, potassium hydroxide, lithium hydroxide, and then you must have to be with some bit of heating, not temperature, because temperature is a different story. So you have to say heat, you understand? Yes, then you'll be able to get the mark. Then you go to question, write down reaction B. Reaction B is substitution reaction that takes place in the presence of water. So we have done with that. So write down the type of reaction that takes place at B. So if you look at B, so we have seen that one. We have seen that one. The type of reaction that takes place at B. So you have seen if that is hydrolysis. Then they say that name 2 other conditions. You have seen that is a strong base, yeah. And then strong dilute base, and then heat. So this is done. Then IUPAC name of compound Y. So compound Y, if you come back, we are always compound Y. So since now this one is gonna follow the Markovnikov rule when this one is forming. So if you look at it, this one is 2, then it means that the the bromine is going to be here, and then, so it means that this compound is going to be like this. The bromine there, and then CH3. And then it means that this one is going to be CH3, CH, and then CH3, and then an OH there. So meaning that, so if you are writing, so it's going to be propan 2, or, so I think we have got it here. Propan 2 all. So that is also correct. Use the structure formula to write down the balanced equation for showing reaction B to C. So when you're saying reaction B to C, B, where is it? B back to C. So if you are removing this, they say reaction B forming Y. Oh, they want this. So automatically what you need to do is when you come here, B is, we say that it's like this. And then you have a bromine here, and then you have CH3, CH2, CH3, and then you have an alcohol here. So we say that here we add a strong base, which is sodium hydroxide, and then you heat. So basically what you want, they don't want this, they say the structure formula. It means that now here you have to write all the bonds, hydrogen, 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 and then you say carbon, bromine here, and then you have hydrogen, hydrogen, hydrogens, you see, and then you have sodium hydroxide, and then you say heat. You understand? Remember, this is should be dilute, so we can say in presence of H2O, and then now you write this again, which is C, CH3, CH3, hydrogen, hydrogen, and then you put OH here. Yes, and then this is a hydrogen, 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 hydrogen. So basically that's how it's supposed to be. And then now, because this one was taking this one away, so plus sodium bromide. So it depends on which base have used. If it is lithium, lithium hydroxide, or lithium bromide. If it is potassium, potassium bromide. So it depends on which base you have used in there. So basically that's how you're supposed to answer that. Then we go to the next question. That's saying the reaction E is a reaction between the major product of alcohol and carboxylic acid to form an ester. Write down the name of the first name of this type of reaction. Name of this type of reaction. So since we are saying that reaction E, major product and alcohol, and then carboxylic acid. Once you have this carboxylic acid and alcohol, then you form an ester. So it is what you call esterification. So that is the type. Sometimes you call it condensation. Condensation. Why? Because you lose some small molecules. Name the organic compound forming during this reaction. Organic compound forming during this reaction. And you look at this reaction, you'll find out that because you form H2O, so the organic compound is H2O. Guys, here they say the name. They're not saying the formula. So if you write it like this, we cross it. So you're supposed to say water, like that. Name the catalyst needed for this reaction. So the catalyst which is needed for this reaction is concentrated sulfuric acid. Concentrated. Name, they're saying name. It is conc sulfuric acid. Don't say conc H like this. We will cross it because they say the name. They didn't say, they just want the name of the catalyst. They don't want the formula. Because if they want the formula, they will say that name, write down the name or formula. So that's when you use the formula. So here you have to write the actual name. So that's why some people, they get it wrong. Yes. Then they're saying that IUPAC name of the functional isomer of ester formed. So if you look at the IUPAC name of the functional isomer of the ester formed, why? Because if you look at alcohol and carboxylic acid here, alcohol, yes, and the carboxylic acid here. So it's 1, 2, 3, 4, 5, 6. So if it is 6, so if it is an ester, the functional isomer is the carboxylic acid. So it's going to become, because it's 6 carbon atoms, therefore it's going to become hexanoic acid. So that's how we're supposed to write it, the functional isomer of the ester formed. So this answer here, it is hexanoic acid. They're saying that draw the structure of structure formula. Now they want the structure formula, not the name of the functional group of the carboxylic acid. Don't forget that the carboxylic acid, they have a carbon double bond at the end. So carbon with oxygen, 2 oxygen at the end. Therefore, here we say that CH. So this is the structure formula. They don't want this, they want this. They want to see, yes, they want to see all the bonds which are involved there. So here, the 1 mark, you'll get it when you write it like that. Then we go to, I think guys, you got all the marks there, 17 out of 17. Yeah, then we go to the next question, which is question 5. Need to be a little bit faster. They're saying that the learners are asked to investigate the rate at which this of impure, this is a key point, impure, the word impure, yeah, react with excess. This is excess, it means that it cannot get finished. Yes, at a temperature, produce carbon dioxide. So the experiment which is shown here is showing that carbon dioxide is produced. They are saying that now, if you look at it, you have the volume here, and then you have the time this side. So the first question is investigative question for this reaction. So what are we trying to investigate about? We want to see the rate at which this is forming versus the concentration. So you can say that what is the relationship between the concentration and the rate of this reaction and the rate of the reaction. So it's investigative question, and don't forget to end with a question mark because they said investigative question. You are trying to find out what is it. So there are so many you can talk about. You can talk about state of division. You can talk about the degree of purity. You can talk about, so all these can be linked to the same question. Yes. Then you can talk about what's the relationship between the state of division and the rate of reaction. You can talk about the rate of reaction affecting affected by the degree of purity. How is this degree of purity affecting the rate of reaction? So all these things can be investigative question for this question. So what is controlled variable? When you look at the controlled variable, what do they control in this investigation? They say that it took place at room temperature. So temperature was controlled. So temperature was controlled. You can also talk about the impurity. Yes, the state of division. You can talk about the mass of impurity. Yes, all those were controlled. Yes. So even concentration was also controlled. So there are so many factors here you can talk about. So what is the dependent variable? Which part is regarded as dependent variable? Or when you come back here, you see that rate of reaction will depend on the rate of reaction will depend on the concentration you have used, you understand, or the impurities, you understand. So rate of reaction is a dependent variable, or you can say the amount of volume formed here will depend on the rate of reaction, you understand. So you can talk about the rate of reaction, or you can talk about the volume of the gas which is formed. Then question 5.2, with the reference to the graph, how will the rate of reaction between 0 and 20 compare to the rate of reaction between 30 and 40? The rate of reaction between 0 and 20. So if you look at 0, from 0 to 20, check, and then 30 to 40. 0 and 20, you see it is a very rapid thing compared to 30 and 40, isn't it? Yes. 30 and 50. check here. It is increasing, but on a decreasing rate. If you check the slope here, yes, the slope here and the slope here, you find out that the slope here is too steep. So we can say that the rate between 0 to 20, between 0 to 20, yes, between 0 to 20 seconds is faster than the rate between 30 and 50. Yes, the rate between 0 to 20 is a little bit faster than the rate between 30 and 50. Then we go to the next question. They are saying that what conclusion can be drawn from the graph between 60 and 70? So if you look at 60 and 70, you see that the reaction has reached its completion. So we can say that the reaction stopped, or the reaction calcium carbonate has been used up. You can talk about hydrochloric acid because hydrochloric acid was in excess. And then we say that it cannot be a limiting factor in that regard. So it's only calcium carbonate which is going to be a limiting factor. So I think that one is clear. Then they're saying use the graph, calculate the mass of the carbonate reacted in this. So we want to know how much was used in this regard. So how much was used? So how much was used in this regard? So we need to know that you're looking for the mass. So if we are looking for the mass, now it means that we need to know the number of moles. So we need to know what is given and what is not given. So let's find out. So if we have that number of moles is equal to number of moles, we know that number of moles, since it is volume which is being produced, so we're going to relate the number of moles in terms of volume is equal to volume over molar volume. You understand? Number of moles is equal to volume over molar volume. So in that regard, we have it, and then we have number of moles is equal to number of moles is equal to. So what we need to find out, they say that the volume is, we have the molar volume. We have the molar volume, which is 24 decimeter cubed. And then we also have, the volume. They say the graph, okay, let's go back here to the graph and then find out. We see that the volume is, for the reaction to complete, is 25. So it means that we have the volume, which is 25 cubic centimeters, which is equal to 0.025 decimeter cubed. And then we have the 24 decimeter cubed. So the number of moles in this regard is going to be 0.025 divided by 24. Yes, and then this will give us 1,042 times 10 to power negative 3 moles. So now, since we have the moles, now we'll be able to calculate the mass. But now, how is we going to be able to calculate the mass? Because here they are saying that calculate. Use the graph to calculate the mass of calcium carbonate that reacted with. So this one is carbon dioxide. You understand? It is carbon dioxide. So we have to use the mole ratio of carbon dioxide to this. So the mole ratio is one calcium carbonate and 1 carbon dioxide. Therefore, it's going to be the number of moles which we use there is the same number of moles so it's the same thing here, the number of moles of calcium carbonate. So since it's the same number of moles, now I will be able to come back here and then I say, what will I say? I will say that the number of moles is going to be equal to, remember the number of moles, we can use still number of moles is equal to mass over molar mass. You understand? So since we have the number of moles, yes. Do you have the mass? We don't know the mass, but we have the molar mass. Do you have the molar mass? We need to calculate it. So calcium carbonate, so it's gonna be for here. It's gonna be 12 there. It's gonna be 16 times 3, which gives me 100. So since I have 100, therefore I'm gonna say here that number of moles, which is, we say that number of moles is 1,042 1.04, yes, is equal to mass, which I don't know, times the 100, which is 100, times 10 power negative 3, yes, times 10 power negative 3, and then times 100. So the number of moles is equal to 10, yes, times 10 power negative 3 times 100, which gives me, is it negative 3 or negative 4? Yes, negative 3. Yeah, which gives me mass to be 0.104 grams. So these are the grams which of calcium carbonate, which was used. So this mass must be smaller than the mass we started with, because here, let's check and find out. They say that they started with how much mass? They started with the, yeah, you see, they started with that. So it means that, yeah, we are able to get it correct. Oh, yes. So they're saying calculate the percentage purity of the carbonate that reacted. So percentage purity, remember, is equal to percentage purity is equal to the percentage of pure sample over the percentage of impure sample times 100, of which now we have the percentage of pure sample, the percentage of pure sample, we calculated it here, which is 0.14, which is 0.14. So it is 0.104, yes, divided by, now the pure sample, impure sample was 0.3 grams. So 0.3. So now it gives me, when you calculate there, not grams, when you calculate there, it gives me, this is times 100, because we want to put it into 100. So it gives me, you see here, the calculator is, it gives me 34.67%. So this is the percentage purity for that. Yes. Then 5.6, they're saying that use the collision theory. Use the collision theory to explain how the increase in the concentration affects the rate of reaction. So for that regard, all right. So you're saying that use the collision theory to explain use the collision theory to explain how the increase in the rate of concentration affects the rate of reaction. All right. So when you saw about concentration, it means that you're increasing the number of particles. So you're increasing the number of what? Particles. So increasing the concentration will increase the number of particles in actual sense. But don't just say number of particles per unit time. The number of particles will increase per unit, not per unit time, per unit volume. Yes. Per that specific volume, the number of particles which are there will be higher. So increase the concentration, increase the number of particles per unit volume, and then now it will have more effective collision per unit time. The effective collision will be there per unit time, and then this will lead to increase in the rate of reaction. So that's how you're supposed to explain the collision theory. You always talk about the number of particles which are colliding effectively per unit time, and then the rate of reaction will either increase or it will decrease depending on which particles are colliding. Then we go to the next question, which is question 6. Question 6, they are saying that potassium dichromate is formed when nitric acid is slowly added to the potassium chromate solution. The chromate ions in the solution reach equilibrium with the dichromate according to the following balanced equation. So here is, you have the equation, define the term chemical equilibrium. Basically, this is a definition. Chemical equilibrium, you are talking about is a dynamic, is when, or sometimes you call it dynamic equilibrium. Yes, dynamic equilibrium is when the rate of forward reaction is equal to the rate of the reverse reaction. The rate of forward reaction is equal to the rate of the reverse reaction. That's it. Saying that more nitric acid is now added to the solution. When you add nitric acid, remember nitric acid is a strong acid. Therefore, it ionizes completely. You understand? It ionizes completely to form hydrogen ions plus nitrate ions, you see? So since you are adding that, therefore it means that you're going to increase this. And once you increase this, then automatically the reaction is going to be favored in that regard. So once you favor the reaction in that regard, then automatically it means that it is going to turn more orange. You understand? It's going to turn more orange. Yes. What color will it, okay, be observed? Choose from yellow or orange. Okay, it's more orange. And then you're saying that explain your answer. So nitric acid ionizes completely. That's what I've talked about. Completely in the solution. Therefore, it increases the number of hydrogen ions reacting, meaning that increasing the concentration of hydrogen ions. And then once you increase the concentration of hydrogen ions, therefore the forward reaction is going to be favored to decrease the concentration of hydrogen ions. So if once the forward reaction is favored, now the number of hydrogen ions are going to decrease and then goes back to normal. So you guys, that is it on that question. Then what are they saying here? They're saying when the temperature of the original reaction mixture is increased, it is observed that the color of the mixture changes to yellow. So the temperature is increased, it means that the color of the reaction, it means that the reverse reaction is being favored. All right. Since you have increased and then it favors the reverse reaction, so what does it mean? So it means that the this reaction is exothermic. It doesn't want substance to be hot. You understand? So basically it is exothermic. Explain your answer, because using the Sheeran's principle, you have increased, you have brought the stress in there, and then now this stress will only be solved by either forward reaction or reverse reaction, depending on which one removes that stress you have increased. So an increase in temperature favors the reverse reaction. Obviously, it favors the endothermic reaction. And then it is the reverse reaction which has been favored. It means that the reverse reaction is what? Is endothermic, and then the forward reaction is exothermic. Therefore, increase in the temperature favors an endothermic reaction. We'll give you a mark there. And then the mixture turns yellow, which indicates that the reverse reaction is favored. You understand? So we say that the mixture turns yellow here. So it means that the reverse reaction, this reaction, the reverse one is the one which is favored due to the increase in the temperature. It means that the reverse reaction is endothermic, the reverse one, while the forward reaction is exothermic. Therefore, the reverse reaction is endothermic, and then the forward reaction is exothermic. So that's how you're supposed to explain it. 6.4. So we are saying that 11 grams, 11 moles. Hey guys, it's saying 11 moles of chromate is okay, and X moles of the acid is initiated together, okay, added together to make this decimeter cubed. So this is the volume. This is a standard volume. They're saying that the solution and solution, okay, allowed it to react. Okay, when the reaction reaches equilibrium, we found out that these moles, not mass, these moles of dichromate is there. And then I saying calculate the pH, calculate the moles of the acid placed in the container. Right, if the equilibrium constant is this, right. So you guys, I usually tell you that I prefer using what you call the rice method. So it means that if I have a chromate, yes, then I have the acid, and then I have the dichromate. You understand? I have the what? The dichromate. Let me say dichromate, and then I put my things there. You understand? And then I say rice method. So what I do here, what I'll do here, these are the number of moles. So we see that from the equation that the equation is on there. We see that from the equation, we see that where is the equation now? Yeah, the equation is 2. Chromate is 2. sulfuric acid is 2, and then the dichromate is 1. So chromate here, 2 moles, and then this 1 mole. Okay, now since you have got that, now I need to go back and find out. How will I know the number, what was used here? Will I be able to know what was used? They talk about it. Here they say that at equilibrium, what's the question? They say that, we found out, when the reaction reaches equilibrium, the solution contains this number of moles. So now we have to go, and then it means that these are number of moles. Said these are the number of moles. Is it number of moles? Yes. When the reaction reaches equilibrium, the solution contains of this dichromate. You understand? It contains this number of moles of dichromate at equilibrium. So now it means that if it is 9 at equilibrium, yes. So it means that at equilibrium here, I will know that we have 9. You understand? At equilibrium. Of dichromate, number of moles at what? Let me check here and then see. Number of moles. Here they say that yeah, saying that there's something I need to check here and I confirm. Oh, these are not number of moles. They are saying this is concentration. So if this concentration, remember concentration is equal to get this concentration. So it means that we have to multiply the number of, to get the number of moles which were there at equilibrium, then automatically we have to multiply the concentration times the volume. Concentration times volume, whereby the concentration is 9 and the volume is, we say that is 0.5. So it means that when I come back here, I'll say that, yes, I will say that it is the number, what was there at equilibrium. So it means that it is, because this is the concentration, this is moles per decimeter cubed, you see. So it means that I'm going to say 9 times 0.5 so that I'm able to get the number of moles, which is 4.5. You understand? Yes. So once I get that, it means that it's the same number of moles which was there, which was produced. But remember, this is a product. This is a product. So since this is volume, and then concentration, and the concentration number of moles is equal to concentration times molar volume, of which the concentration is 9 and then the molar volume is 0.5. Yes. That's why I'm able to get this number of moles. So these number of moles are the same number of moles which were produced, because it's a product. But using the mole ratio, 1 mole of this we require 4 moles of the 2 moles of this. Therefore, this is going to be 9, and then this is going to be 9. Once I get that, we see that we don't know how much, because we don't know how many moles did we start with. You understand? We don't know how many. No. I need to put here how many moles did we start with here. So if this is 0.9, the initial moles, let me just this one I misfired here. Let me just make it right so that okay, let me just rectify it properly so that we're not confused. So what I was saying, that I wanted to draw this properly. They're saying that what I was saying that is here we have we at equilibrium we found out that we have this. It means that this was produced. Yes, so that was produced. So automatically, what was there at the beginning? What was there at the beginning? We started from 0. So this was produced and this was the equilibrium. You understand? Then automatically, what was there at the beginning, we don't know. And what was here at the beginning, Let me check here. They say that 11 moles of chromate. So it means that this is 11 moles. So what is the difference? What was left there at equilibrium? At equilibrium here, it's going to be 11 minus 9, which gives me 2. Well, here is going to be x minus 9 because I don't know what the initial moles. And then now I have to find out it's going to be 2 over 0.5 so that I'm able to get the concentration. So that is the concentration, while here is going to be x minus 9 divided by 0.5. So now since I have this, then I'm able to put it in the expression for Kc. So the Kc expression, so the Kc, they say that what is the Kc here? 0.009, 0.009, yes. But you have to put the things correctly in the Kc. So Kc is equal to, is going to be dichromate, yes, dichromate 0.70, okay. Yes, concentration divided by chromate, yes, chromate, and then remember it is 2 number of moles, yes, based on this 2 moles, and then the acid, which is also 2 moles. So now from there I am gonna substitute properly 0.09, which is the Kc is equal to 9, yeah, which is this 9, yes, divided by, yes, now for this it's gonna be 4, but is squared times 2x, yes, 2x minus 18. Or I just bring it the way it is, so that I just did this so that I remove this fraction. Do you understand? Yes, 2x minus 18 squared. So now once you look for x, you'll find out that x is going to be equal to 10.25 moles. So that is how it's supposed to be answered in that regard. So guys, I think that question is fine and clear, and you're able to get it right. Then we go to the next question, which is question 7, a solution of carbonic acid. Carbonic acid is, that is acidic rain, which is this pH, and then the Ka value is that. So the Ka value of this, okay, they're saying the solution of sulfuric acid has the following Ka, okay. They have different Kas, but this one is too small, one is too high, meaning that this one has a lower dissociation. The dissociation is too low, meaning that it's a weak acid, while this one, the Ka is high, meaning that it is a stronger acid. Then they're saying that calculate the concentration of hydrozonium ions in carbonic acid. Obviously, you're going to say that pH is equal to negative log of hydrogen concentration, whereby the pH, they're saying concentration pH of this, we say that the pH is 4.2. 4.2 is equal to negative log, yes, of the concentration of this. You understand? Negative log of the concentration of this, which is negative log of concentration of this, which is carbonic acid. Yes. So it means that, remember, this is base 10. So if it's base 10, so it means that I'm gonna say the concentration of this is equal to 10 to the power negative 4, because it's negative log. Therefore, 10 to the power of this. Yes. So that once I get that, it is gonna be, the concentration is gonna be equal to the 10 to the power of 4.2. And then once you get that, you'll be able to get the, which is equal to 631 times 10 to power -5 to power -5. And what is this? Moles per decimeter cubed, or molar, whatever. You can say molar or moles per decimeter cubed. So that's how you're supposed to calculate that. And how will the strength of carbonic acid compare to that of sulfuric acid if both acids are of concentration? It's going to be, carbonic acid is going to be weaker. Why? Because carbonic acid ionizes, has a small Ka value. See here, why it dissociates partially. So when it ionizes partially. When you put it in water, when you try to dissolve it, it dissociates partially, meaning that it has a small amount of ions which it produces. All right, then we go to question 7.1. They're saying that define hydrolysis. When we talk about hydrolysis, reactions which involve water. So hydrolysis is a reaction of salt with water. So you have a salt and then you have water. Yes, basically that is it. Then they're saying that will the pH of sodium carbonate greater or less than that? So what will happen to the pH of sodium carbonate, sodium acetate, sodium carbonate, be greater than or less than? So basically it is gonna be greater than. Why? Because sodium acetate is a weak, what? It's a weak salt. So since it's a weak salt, therefore it means that the pH is going to be a little bit higher. It's going to be more of basic than being the acidic. Then we have the next question, which is explain the answer above using the equation. So okay, if you look at when you dissolve the pH, when you dissolve it, so what is going to happen is the let me first write the acetate here. You understand? So now when you add H2O here, you understand? You're going to produce the carbonic acid. No. The oxalic acid. You're going to produce oxalic acid or ethanoic acid, what you call the ethanoic acid. You understand? Then plus, ne? This one will come, this hydrogen will come and join here. Then you're going to have an OH here. So because this hydrogen joined here to form this, then you're going to have an OH, which is a base. This base is going to make the pH to be a little bit higher. So it means that you guys, they wanted you to write this and this. Yeah, or even you can write it as sodium acetate. Like you add, instead of making it an ion, you write the sodium plus there, here, sodium plus, and that's it. Saying that 7.3, they're saying that unknown carbonate has a chemical formula of Y. Chemical formula of what? Of Y. So if you have a chemical formula of Y, a learner is asked to identify element Y. So we want to identify element Y. So what is element Y? So we need to do the calculation and then find out. Learner, okay, you have this mass of carbonate in a conical flask containing 25 cubic centimeter of hydrochloric acid with the concentration of this. The balanced equation for the reaction takes place is, okay, you have this, okay. Hydrochloric acid in excess. Once you say it's in excess, it means that it cannot be used as a limiting reagent. Calculate the initial volume of hydrochloric acid in the conical flask. So in this regard, we have to calculate the initial volume of in the conical flask. So we need to find out. So initial volume of volume of moles, initial moles. So what do we have? We have the volume, we have the mass, we have the concentration. Do you understand? So since we have the concentration, so we can relate the number of moles to concentration and volume. Do you understand? We say that, we're going to say that number of moles is equal to concentration times volume, the molar volume. Do you have the concentration? Yes. Do you have the concentration? Yes, we have the concentration. Do you have the volume? They said 20. So when you say calculate the amount of hydrochloric acid in moles that reacted with unknown carbonate. So in this case, we are looking at the amount, they are saying calculate the amount of hydrochloric acid. So we're doing this, the amount of hydrochloric acid in moles, meaning that you're looking for the moles that reacted with unknown carbonate. So I need to know how much reacted with this with the sodium hydroxide. See? Yes, so for that reason, I'll say that I'll need to know number of moles, and do like this, number of moles, N of sodium hydroxide, so that I'm able to use that with the mole ratio, sodium hydroxide to hydrochloric acid, and then I'll be able to know, because sodium hydroxide is known. So number of moles is equal to sodium hydroxide is equal to concentration times the volume, of which this will be equal to, do we have the concentration? Have to go back and find out. Have the concentration of 0.1. See, so concentration is 0.1. Sorry, concentration is 0.1 times volume. The volume, do you have the volume? Let me find out. The volume is given. Yes, the volume is 15 cubic centimeters. So it means that I have to change this 15 cubic centimeters divided by 1,000 so that we give it to decimeter cubed. So which is 0.015 decimeter cubed. So it means that is times 0.015. So the answer I get here will be 0.00 point, if you divide 0, this goes there, so 0.00515. Yes, what is this? These are number of moles of sodium hydroxide. It's supposed to be a capital O, hydroxide. So once I get that, now I'm going to use the mole ratio of sodium hydroxide with the hydrochloric acid, and I know how much. So if it is sodium hydroxide from the equation, we'll find out that sodium hydroxide on this one, if you look at, there is not here the equation, but if you write, remember this is a neutralization reaction. So if I say that, remember sodium hydroxide plus HCl, it gives you sodium chloride plus H2O. Salt, a base plus an acid, you get a salt plus water. The mole ratio is 1. Even this one is 1. So it's 1 to 1. So it means that this is 1 and this is 1. Understand? So isn't the mole ratio is 1 to 1. So automatically these are the same number of moles. So number of moles of hydrochloric acid will be equal to 0.0015 moles. Understand? Why? Because the mole ratio is 1. So once I get that, then I have to calculate the initial moles. You understand? I need to know the initial moles of hydrochloric acid. Yes, of which I calculated already. Then minus the hydrochloric acid left. This is the hydrochloric acid left. Number of moles of hydrochloric acid left. Why am I saying number of moles of hydrochloric acid left? Because these are the number of moles which reacted with what? With this. These are number of moles which reacted with sodium hydroxide. It means that those are number of moles which left. Understand? Yes. So it means that I will say that HCl, yes, automatically we are talking about number of moles. Yes, we're talking about what? Moles minus the number of moles still. Let me just say number of moles HCl initial minus HCl, the one which reacted with sodium hydroxide, meaning that left. You understand? These are number of moles. The number of moles. Yes, this will be equal to the initial one. We should go back. The initial we calculated say 0.0. Calculated it to us. Where is it? I think I rubbed it off. Yeah, we calculated it. When we calculated it here, yeah, the initial. We calculated. I can't find it. Okay, let me just clear it up. Yeah, the initial. Remember we said that. We said that. Okay, the final we have it, which is 0.0015 moles, and then the initial. We say that if we do small calculation here, say that number of moles is equal to concentration times volume. So which those number of moles, simple, you see, it's here. So those number of moles, we say that number of moles is equal to concentration, of which the concentration here is 0.3. Yes, the concentration here is 0.3, and then the volume is 25 cubic centimeters divided by 1,000, which gives us this times 0.025. Understand? Decimeter cubed. So basically, so the number of moles will be equal to 0.01. Yes, moles. So this is the number of moles of this. Understand? The initial one. So I'll come here and I'll say that, yeah, the initial one is 0.01, yeah, 0.01 moles minus the one which were reacted with the sodium hydroxide to neutralize it, meaning that that was the excess which was there. So it gives me 0.0085 moles. Understand? 0.0085 moles. So basically, that is it. That is it. So from there, we shall say that identify element Y. Show your work, your calculation. Here it is 5 marks. So we need to find out what is that. So since now we know at least what reacted, which reacted. So we need to know now the number of the mole ratio. We need to find out the mole ratio. Since now we know most of this information, we know this information. Understand? So we can take the mole ratio of this so that we know the number of moles. So now we're gonna say that number of moles of Y2 carbonate, yes, will versus the number of moles of HCl. So HCl, which HCl, this is a number of HCl, number of moles that reacted with this, you understand, with the Y2 carbonate, of which we don't know what is this Y2 carbonate. So now, if you come back here, you'll find out that it is 2 to 1. So we shall say that this is 1 and then this is 2. So since I have the number of moles that reacted, so it means that Y2, the number of moles which reacted. So I have the number of moles which reacted, which is this. Understand? Yes. So since I have those number of moles which reacted, So it means that of hydrochloric acid, then automatically I have to divide it so that I get for Y2. So 0.0085 divided by 2, which gives me, so that I'm able to get the number of moles for this, which gives me 0.00425 moles. Understand? Yes. So that is it. Now, since I know that, then now I'm going to say that number of moles is equal to mass over molar mass, of which I have the number of moles 0.00425 is equal to number of, we don't know the mass. Do we know the mass? We don't know the mass. What are we looking? Molar mass. So that we are able to substitute there. Do you know the mass? Let's find out. I use that kind of mass, so automatically it means that I have the mass, which is 0.5865 divided by that which is capital M, which is the molar mass. So automatically, if it means that this is gonna go there and then this is gonna go down, which means that I'm gonna get the molar mass as, if you put it in your calculator, this divided by this gives you that. So it means that it's gonna be 138. So this is the molar mass of Y2 carbonate. Since now I know that, yes, so it means that I can find out this carbonate, the molar mass, plus this Y2 is equal to this. So I will say that, therefore, Y2, yes, plus the carbonate, which is 12 plus 16 times 3, understand, is equal to 138. You understand? So now it means that I'm going to group up this. When I group it up, it is 60. So it means that Y2, yes, Y2, yes, is equal to 138 minus 60. So I put this one this side. So Y2 is going to be equal to, it's going to be equal to 78. Understand? But now since it is Y2, meaning there are two atoms of this, so it's equal to 78. Therefore, I'll say divided by 2, so that I get Y, because they want Y. They want Y, they don't want Y2. They want this. So automatically, I'll say that when you divide by 2, so it gives you 39. So I'll go to the periodic table and find out which element has that. So if you go to the periodic table, you'll find out that Y2 is equal to potassium, which is potassium. So we shall say that that is the answer for that compound. However, you can have other different options, of which those different options, different calculations. Yes, you can have different options. So it's better to say potassium instead of writing just like this. And then we go to the next question. Yeah. You might have different methods of doing this, but sometimes when you use different methods, you end up not finding the element on the periodic table. So I prefer using that for that case. Yes. So we go to the next question, which is saying that question 8. You have question 8, you have question 9. So we expect to finish it soon. Then they're saying that a galvanic cell, remember these are cells which produce energy, is constructed as shown in the diagram below. Okay. You have here cadmium, you have nickel, then meaning that solution is here. So which electrode is cathode, right? Only nickel or cadmium. So in this case, you look at which one is the most reactive and which one is less reactive. Remember that reduction at the cathode, meaning that the less reactive is meaning that the nickel and the cadmium, which one is more reactive, which one is less reactive. If you look at it on the periodic table, you'll find out that cad is up while nickel is down. So it means that nickel is less reactive. So it becomes the cathode where reduction takes place. So in this case, I'll say it's nickel. Write down but use the reactivity oxidation table, this one. Yes, this one. Usually use this one. Understand? So it's better. You identify it. You have nickel there. Understand? Yes. You have card here. You see? And then you have nickel here. Let me clear it up. The one which is above is more reactive, therefore it is oxidized. And then one which is down is less reactive, therefore is reduced. So you have it here and you have nickel here. So it means that this is going to be the anode, while this one is going to be the cathode, meaning that this one is going to be oxidized, then this one is going to be reduced. Yeah, that's the meaning. So that's why here we have it like that. That this one is the cathode. Write down the equation for the oxidation half reaction cell for this reaction. The saying oxidation half oxidation. Write down the equation for oxidation half reaction for this cell. So if you are looking for the oxidation half reaction, since we said that nickel is a reduction, so it's going to be, what's going to happen to it is going to be cadmium. Yes, cadmium. It's going to give you cadmium 2 ions. So since the 2 ions plus 2 electrons. So it's a solid and this is aqueous. Then you're able to get the 2, or you're able to get the max. Then they're saying that will the reading on the voltmeter be affected if concentration of nickel ion is increased after the cell has reached equilibrium? Choose increase, decrease, or remain the same. So how will the reading of voltmeter affect the concentration of the nickel ion is after, if the concentration of nickel ion? Definitely if you increase the concentration of nickel ion, the reaction will increase. Give a reason for your answer. Because you have increased, there is increase in the nickel ion concentration, which will favor the forward reaction. Therefore, the reaction will continue. So it can favor the reverse reaction, or it can favor the forward reaction. Since here nickel is at the cathode, then automatically it's gonna be favored. Then they are saying that the forward reaction is gonna be favored. Then they're saying that consider the following electrochemical cell. This, okay. Initially, it had this kind of volume of electrolyte. The connected circuit allowed to produce current until the concentration of this. Okay. They're saying that the cell is then disconnected. Write the balanced equation for this reaction. So they are looking for the balanced equation based on this. Yes, it's gonna be this yes, plus, because this is salt bridge, this plus this gives you this plus that. Understand? Yes. So it's gonna be, it's gonna be copper solid plus silver iron. So copper solid, silver iron gives you copper to iron plus silver solid. Yes, that's the meaning. But now, this is balanced, né? Yes. Copper to, yeah, this is 1. Silver is 1. So automatically, I will say 2 here. Yes. I'll also say 2 here. So that these 2 times 1 gives you 2 positive 2 charges. So I need 2 molecules of silver to deal with 1 mole of copper. So that's the equation. That's how it looks like. Basically, when you're balanced, when you are marking, we shall mark this, we shall mark the product, and then we shall mark if it is balanced. Yes, that's how we mark. That's how you get these 3 marks from. Calculate the amount, calculate the concentration of electrolyte in the electrode half cell when the cell is disconnected. So in this case, we are looking at the calculate the concentration of electrolyte in electrode half cell when the cell is disconnected. So in this case, what are we supposed to look at? We need to look at the concentration of silver. Let me use the whiteboard so that you're able to see what we are trying to calculate. So in this case, we need to find out what happens at the cathode. Because why the cathode? Because that's where the details is provided from. So now we are looking at the cathode. You see? Cathode reduced to this. So since we know that, because the details, at least we have the concentration and we have the volume, therefore we can start from there. So it means that the concentration at the cathode, remember, it is silver. So the number of moles of silver, yes, that reacted will be equal to C over V. C times V, not C over V, of which we have the concentration as 0.5 times the volume, which is 0.2. Why am I saying that? 0.5 the concentration, 0.2 the volume, which is 200 divided by 1,000. So it gives me that. So now here I get, what do I get? I get 0.1 moles. Understand? Yeah, once I get that, I continue, and then I say that the number of moles is equal to copper. Yes. Number of moles of copper reacted, because now I know at least. So you can use more ratio, so that I'm able to know number of copper reacted versus the number of moles of silver. Remember, silver require 2 moles, while copper require 1 mole for this reaction. So now automatically, I will say that 0.1. So if I want to get this, I will have to divide, which is 0.1 divided by 2, which gives me 0.05 moles. So this is the number of moles of copper which reacted. So basically, this is copper. Understand? Number of moles of, let me just say like this. These are the number of moles of copper which reacted. So since now I know that, yes, now I will go back and find out. I'll go back and find out, okay? I will find out that what will happen at the anode. Since I have now the number of moles of copper, now I'll be able to know what happened at the anode. You understand? The number of moles of copper that reacted is equal to the number of moles of copper that was released. Why? Why am I saying like that? Because copper to copper, copper, one copper, one copper. So it's the same thing. So since I know that, now I'll come back here and I will say that, I'll come back here and I will say that number of moles of copper. So now here I'm at the anode. Let me just write it, anode. Yes. So it's going to be copper, remember, gives me copper 2 ions plus 2 electrons, isn't it? So meaning that 1 mole of this is 1 mole of this. So if this one, if the number of moles of copper is 0.05, automatically even this one's going to be 0. Number of moles of copper produced, it's going to be 0. Did I write it right? No. 0.05 moles. Are we together? Then from there, I need to know what was the number of moles of copper initially. I need to know that. Copper, number of moles of copper. Yes, copper 2 ions initially. Yes, they were, let me say initial. Understand? Initial is equal to copper volume. Understand? Copper and volume, like that. So I will say that number of moles of copper, it was 1 mole. Yes, why do I say 1 mole? Because they said it here. Number of moles of copper, 1 mole. Then here is 1 mole. Yes, so number of moles of copper, which is 1 mole, times, there is a number of moles, the concentration of copper. Yes, concentration is 1 times the number of moles, times the volume, which is, they say is 200. 200. Yes, 200. So 200 divided by 2, divided by 1,000, it gives them 0.2. So now, number of moles of copper initially is going to be equal to 0.2 moles. See? Since once I know that, now I'll be able to identify the number of moles of copper. Yes, final. How am I going to get it? It's going to be equal to the number of moles of copper, understand, 2 ions initially, which was there, plus the number of moles of copper, which was released. Number of moles of copper, 2 ions, yes, which was released. So now I know the number of moles of copper initially, which is this. Yes, this, see, 0.2 plus the number of moles of copper, which was released, which is 0.05. 0.05. Understand? Then since now when I add, I'll be able to get 0.25 moles, meaning that this is the number of moles, of copper with 0.25 moles. Yes, those are the number of moles of copper, which was at the final stage. You understand? Yes. But what do they want? They want they want the concentration of what? Of copper, 2 ions at the end. You understand? Yes. So I will say that if you come back here, they say that calculate the concentration of electrolyte at the anode, have equation when the cell is disconnected. You understand? So when the cell is disconnected, then I will say that the concentration will be equal to number of moles over volume, of which concentration is equal to number of moles, which is 0.25, over volume, which is 200, remember it was 200 cubic centimeter, divided by 1,000, so which gives me 0.2. So divided by 0.2, then the concentration of copper, yes, the concentration of copper, let me just do like this. The concentration of copper, concentration of copper 2 ions will be equal to, yes, it will be equal to 1,25 moles per decimeter cubed. Or you can say 1.25 mole. Yeah, it's the same thing. Moles per decimeter cubed is the same as molar. So that's how you are supposed to calculate this. Yes, that's how you're supposed to calculate that. Then the last question is about electrolysis is generally used in the industry to produce chemicals through decomposition of compounds. The simplified diagram below represents the electrolytic cell used in the electrolysis of concentrated sodium chloride solution, isn't it? And they're saying that define the term anode in terms of oxidation or reduction. An anode is an electrode where oxidation takes place. Remember we said that red cat and then anox. Reduction at the cathode, oxidation at the anode. Oxidation at the anode. Yes. So that's how an electrode where oxidation takes place. Which electrode X or Y is connected to the positive terminal of the power source? Give a reason for your answer. So if you look at this, it is meant to be X. Yes, it is meant to be X. Yeah, but some small information was not given. Yeah, so the terminal is X. So what is the why? Because this is concentrated sodium chloride. Sometimes we call it brine. Yes, it contains chlorine ions or chloride ions that will be oxidized. Yes, at the electrode, which is X. So it means that, so if since it contains sodium chloride, which is concentrated, meaning too much chloride will be there. So the too much will outcompete others, and then that will be the direction. Yes. Then which compound C? What is compound C? Since what's compounds? Okay, compound C. They're saying what is compound C? Compound C is chlorine, gas. Yes. However, hydrogen gas can also be accepted in this regard, but we prefer it being what? Chlorine gas. Then they're saying that write down. So this is chlorine gas. Those who wrote hydrogen gas could be also correct, or they could be, maybe they will give you a credit there. Write down the equation of half cell, okay, at the cathode. Yes, at the cathode. So in this regard, it means that water is going to be, the hydrogen gas is going to be produced. So it means that water is going to be electrolyzed. So it means that whenever you write H2O, gives you hydrogen gas plus what? Plus OH. So when you balance the equation, you will have a 2 here. You will have, because here I have, it's negative 2 electrons. So automatically I will have to add here an electron. So if you have an electron here, so this is 2. So since this is negative 2, automatically there will be another 2 there. So that is the answer in that regard. Yes. So did I write it? No. Yes, I wrote this one wrong. Yes, I said this is water. and then this is what? Chlorine gas, or it could be hydrogen. Yeah. Someone is asking, yes. So refer to the relative strength of oxidating agent. Explain the answer to your question. So we see that water is a strong oxidizing agent than sodium. Therefore, is reduced to hydrogen. Hydrogen what? Hydrogen gas. So water is a strong reducing agent, meaning that is a strong oxidizing agent. So since it is a strong oxidizing agent, it will accept these electrons, and then it is reduced to hydrogen gas. That's why you're able to collect the hydrogen gas in that regard. So you guys, I think the paper was relatively fair, and I hope you guys will be ready to prepare this upcoming paper. The next writing. So I wish you the best in the upcoming exam, and I know that you guys, you will make it to your universities where you're gonna be having different courses. Thank you so much.